In a daring announcement, researchers have revealed the identification of a completely new planet, unlike any other discovered before. NASA, renowned for its trailblazing research, has shared that this newly uncovered planet is fascinating not just due to its size and location, but also because it radiates light that seems to be artificial. Could this revolutionary find signify that we are on the verge of unlocking secrets that will radically transform our understanding of the universe? Does this spark curiosity about the potential for life on planets beyond Earth? As we dive into NASA's incredible revelations, we may soon uncover the truth behind these extraordinary illuminations. In 2007, NASA launched the Dawn probe with the objective of investigating some of the most intriguing objects in our solar system. Equipped with 3 ion propulsion engines, Dawn began a mission that kicked off with a 14-month survey of Vesta, the second-largest asteroid in the belt. Dawn transmitted back detailed pictures and data, unveiling Vesta's complex surface and rich geological history. Upon completing its assignment at Vesta, Dawn proceeded with what was arguably the most thrilling phase of its journey, an in-depth exploration of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a task that traditional chemical propulsion methods could not have achieved. These engines provided a steady thrust, allowing Dawn to cover immense distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object within the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, making it one of the most fascinating objects due to its unique features. Scientists eagerly anticipated the first high-resolution images of this mysterious world, which revealed bright spots scattered across its surface, particularly inside a large crater called a Cater crater. These luminous spots instantly captured the attention of the scientific community. Before the Dawn mission, the best pictures we had of Ceres were blurry, low-resolution shots taken by the Hubble Space Telescope. Little was known about the dwarf planet, and the prospect of receiving close-up images promised exciting new insights. The Dawn mission aimed to deepen our understanding of the solar system's formation and the role that water played in shaping planetary bodies. The bright spots on Ceres, which were also noticed on other asteroids, were thought to be composed of highly reflective materials, likely salts left behind by evaporated water. This discovery suggested the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes expel not molten rock, but liquid water or brine. What exactly these enigmatic lights are and what they reveal about Ceres remains an open question. Could they be signs of ongoing geological activity? Or might they indicate something even more astonishing? Ceres stands apart from other bodies in the asteroid belt due to its size, mass, composition, and potential for harboring water and ice. Unlike typical rocky asteroids, Ceres is made up of a mixture of water ice and volatile materials, which means it may hold valuable secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a crucial moment in its mission as it prepared to send back the first close-up images of the largest object in the asteroid belt. The spacecraft drew nearer to Ceres, unveiling a world previously hidden from view. The initial pictures of Ceres displayed a cratered surface indicative of a long history of impacts. However, it was the bright spots scattered across the dark, rocky terrain that seized the attention of scientists and space fans. As the resolution of the images improved, scientists proposed various hypotheses about these spots. Could they be patches of ice reflecting sunlight, or could they represent something even more unusual? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer scrutiny revealed that the brightest spot was not a single feature but a cluster of several distinct spots. The most widely accepted explanation was that these spots were deposits of salt left behind by the evaporation of water. This suggested that Ceres may have, or still does have, some form of geological activity capable of bringing water or brine to the surface, where it quickly sublimates, leaving behind bright, reflective residues. These revelations challenged prior assumptions about Ceres, providing a fresh perspective on a dynamic and complex world. The possibility that groundwater or brine pockets exist beneath the surface raises exciting questions about the potential for life elsewhere in our solar system. Ceres is often described as an icy world with a rocky yet porous exterior. Unlike most asteroids, which are composed primarily of rock and metal, Ceres stands out for its unusual makeup. Its surface is made up of a mixture of water ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition implies that Ceres contains a substantial amount of water. Its rocky surface is porous, with ice and other volatile substances trapped inside, making it more like a comet than a typical asteroid. Scientists believe that Ceres has a unique interior consisting of a muddy mantle and a core rich in water ice, which constitutes about 50% of its total volume. The mantle is thought to be a blend of rock and brine, encasing a core potentially made of denser materials like silicates. The presence of significant water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was warmed by radioactive decay early in its history. This interior structure distinguishes Ceres from other asteroids and raises fascinating questions about its potential for geological activity and the role of water in its development. Moreover, the discovery of ammonia clays on Ceres points to the possibility that the dwarf planet may have originally formed in a cooler region of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, supporting the existence of surface brine. These insights into the composition and history of Ceres not only deepen our understanding of this captivating dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a captivating and relatively rare geological phenomenon. Cryovolcanism on Ceres. Cryovolcanism is a fascinating geological phenomenon, especially when compared to the more familiar volcanic activities on Earth. Unlike traditional volcanoes that eject molten rock, cryovolcanoes are often referred to as ice volcanoes, as they release substances such as water, ammonia, or methane. These materials can exist as liquids or gases in extremely cold environments, such as those found on Ceres. Cryovolcanoes on Ceres operate by allowing salty water with dissolved minerals to reach the surface. When the salt water comes into contact with the vacuum of space, it rapidly sublimates, turning directly from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater called a crater, specifically in an area known as Spot 5. This region has attracted significant attention due to its high reflectivity and periodic fluctuations observed by the Dawn spacecraft. These changes are believed to be caused by water sublimation, implying that cryovolcanic activity could still be taking place or might have occurred recently on Ceres. In addition to Spot 5, Ceres contains several other bright spots, each with distinctive features. These spots are not concentrated in one location but are spread across the dwarf planet's surface, suggesting that cryovolcanism could be a widespread phenomenon on Ceres. The existence of these bright spots highlights the active and evolving nature of Ceres, challenging previous assumptions that it was a geologically dormant world. As the Dawn spacecraft continued to capture more detailed pictures, a diverse array of surface features emerged. Ceres' surface is covered with numerous craters, each revealing the story of this dwarf planet's history. Let me know your thoughts in the comment section. And if you enjoyed this video, remember to like and subscribe. As the Dawn spacecraft proceeded with its study of Ceres, the scientific community remained captivated by the planet's enigmas. Each new discovery raised more questions about the dwarf, planet's past, and its potential to support conditions conducive to life. The presence of bright spots and signs of cryovolcanism painted a picture of an active world, far more dynamic than originally believed. This discovery suggested that Ceres might not only be a relic of the early solar system, but also a planet where ongoing geological processes, such as the eruption of ice and brine, are still shaping its surface. The fact that Ceres could maintain such activity despite its small size challenges conventional thinking about celestial bodies in the asteroid belt. Traditional beliefs held that small bodies, especially those located in colder regions, were likely to be geologically inactive and frozen in time. However, Ceres' ongoing activity suggests that even in the cold, distant reaches of the solar system, the right combination of heat, water, and salts might be enough to drive cryovolcanic eruptions. Another important aspect of Ceres is its potential to reveal key information about the history of water in the solar system. Water is a crucial element for life as we know it, and the discovery that it may exist in liquid or brine form on Ceres opens up new possibilities for the existence of life in environments far from the warmth of the sun. The idea that water ice and liquid water could have once existed on Ceres suggests that other similar bodies in the solar system, such as Jupiter's moon Europa and Saturn's Enceladus, may also harbor conditions favorable for life, making them prime targets for future exploration. The possibility of cryovolcanism occurring on Ceres also raises further questions about the mechanisms that drive such activity. How does the water beneath Ceres' icy crust remain in a liquid state despite the freezing temperatures of space? Could there be an internal heat source, such as radioactive decay or tidal heating from gravitational forces, that keeps the water beneath the surface warm enough to remain liquid? Understanding the nature of these internal heat sources could offer valuable insights into the geological evolution of other icy bodies in the solar system. Ceres' dynamic surface features, from its bright spots to its craters, help us better understand the impact history of the solar system and the ways in which smaller bodies have evolved over billions of years. Every crater on Ceres, each distinct in its formation, gives scientists a glimpse into the forces that have shaped not just Ceres, but many similar bodies throughout the solar system. Whether these impacts were caused by asteroid collisions or other cosmic events, they contribute to the unique character of Ceres and its role in the broader narrative of the solar system's development. Moreover, the presence of ammonia clays on Ceres offers another captivating clue about its history. Ammonia is known to lower the freezing point of water, which could have allowed liquid water to exist on the surface in the past, or even today. This discovery suggests that Ceres may have originated in the colder outer regions of the solar system before migrating inward toward its current position. This migratory history could explain many of the intriguing features seen on its surface, including the presence of ammonia and signs of cryovolcanism. As scientists continue to study Ceres' surface and interior, their findings are reshaping our understanding of planetary formation, the potential for life beyond Earth, and the processes that drive geological activity in the outer solar system. Ceres, once considered just another small, cold asteroid in the belt, has emerged as a captivating world that defies our expectations and invites us to reconsider what is possible on distant worlds. The Dawn spacecraft, through its years of careful observation, has played a crucial role in uncovering these new details about Ceres. The mission, which has delivered the most detailed images and data of this faraway dwarf planet, continues to be a cornerstone in our exploration of the solar system. Each new image transmitted back from the spacecraft reveals more of the planet's secrets, showing a complex and ever-evolving world that was once largely unknown. These discoveries are only the beginning of what promises to be an ongoing exploration into the mysteries of the outer solar system. In the years to come, the scientific community will undoubtedly continue to analyze the data sent back by Dawn, searching for more clues about the potential for life on Ceres and similar bodies in the solar system. As technology advances and new missions are launched, even more unexpected revelations are sure to come. Will we uncover more signs of cryovolcanism or discover even more evidence of water beneath Ceres' surface? Only time will tell. But one thing is for sure: the story of Ceres is far from over.